If you've worked with anything JavaScript, chances are you've seen these three things: package, package-lock, and node modules. This is a big source of confusion, especially for beginners, so in this video, I'm going to break down exactly what each of these three things are, exactly how they work together, and how the entire package system using NPM functions in JavaScript land. If you stick around to the very end of the video, I'll also give you a very simple best practices guide to follow that will ensure you use the package system like a professional dev. Before we start, I want to acknowledge that there are other package systems like Yarn and Bun that are rapidly increasing in popularity, but because NPM is still the most widely used and most common by a large margin, that's what we'll be focusing on in this video. If you already know what a package is and don't need a super high level overview of NPM, you can go ahead and skip to this timestamp right here. Otherwise, if you're new or just need a refresher, that's what we'll start with. Let's get it. We're going to start completely from a blank slate and make this video completely framework agnostic. So whether you're using vanilla.js, React, Vue, Svelte, whatever it is, doesn't matter. The first question we need to answer is this: what are packages in JavaScript? It's simple. A package is code that somebody else wrote that you can add to your app. That's all it really is. Somebody wrote code that does a specific thing, you want to do that specific thing in your app, but don't want to rewrite it from scratch, so you use a package. Some examples of popular packages include Axios, React, Tailwind CSS, Vite, and so much more. Basically, every important web dev technology you've ever heard of is a package. Every framework, every utility, they're all packages. What this means is that essentially the entire web dev sphere revolves around packages. If you're building modern web apps, there's a 0% chance you're going to build without using any packages. In fact, chances are you're going to have significantly more package code in any modern web app than your actual code. I'd go as far to say that 90 to 99% of all your code is going to be from packages. So buckle down because we need a solid understanding of packages to be a web developer in this day and age. As I mentioned a second ago, packages are just code that somebody else wrote. This code that other people wrote has to be stored somewhere before we can use it. This is where NPM comes in. NPM is the world's largest repository for JavaScript packages. Whether it's a framework like React or Angular or anything else, every single package in the JavaScript ecosystem is on this website. Literally every single one. Billions of packages are downloaded every single day. It's essentially GitHub for packages. And in fact, it's owned by GitHub, so that's part of the reason behind its success. If I want to look at any package, I can come up here to the search bar and search React, for example. Have a few options here. I can click into React and we'll get a basic page for the React package. Usually on this page, there will be some basic information like a very broad overview of the package and how to install it. And some basic stats like telling us that React has 40 million downloads per week. There's a few other things like being able to view some code and being able to view the dependencies and dependents, but I'll elaborate on that more in just a minute. Basically, we can find any package we want on this NPM website. If you want to know whether a package exists or is on NPM, you can just search it up here. Or you can just go into Google, do something like NPM package name like this, whatever package you want to search, and it should usually come up as the first result. Another example of a super famous package is just Tailwind CSS, so we can search it here, click on this, and now we're at the page for Tailwind. Again, getting some basic information and some overview stuff, but really for what I'm trying to show you right now, this page is not super important. Let's move on how to actually utilize the package system. In order to utilize this entire NPM package system, you'll have to first install NPM on your computer. It's nothing crazy, you just need to install it with Node. If you've done any JS development ever, you probably have Node, so you don't have to worry. But if you don't have it, you can go to nodejs.org here and just download Node, and NPM comes as a part of Node. Once you have this, you're good to use NPM. Now that we've covered the extremely basic overview of packages, it's time to talk about the core of the NPM system. The first and actually most important part of the package system in your JavaScript code is going to be a file called package.json. There is a 99.9% chance that whatever framework you're using for web dev is going to set up this file for you. If you're using Vite with your framework of choice, which you definitely should be, it will automatically set up package.json. However, if you need to get a package.json from scratch, open up your terminal, make sure you quickly have npm by typing npm-v, and it should tell you the version. That's so you know it's installed. And once you've verified that it's there, you can run the command npm init-y just like this. This is the command to initialize your project as one that uses npm. Once you've ran this, you're free to use npm however you'd like. The main thing that running this command will do is generate the super important file package.json, which looks just like this. This file right here is the single most important part of packages in your entire app. So what is this file and what does it do? Well, in order to understand what package.json does, it's critical to understand the layers of the NPM system. NPM is built on 3 layers, no more, no less. Package.json is your very first layer, package-lock.json is your second layer, and node modules is your third layer. This order never changes, so memorize this well. Package.json, then package-lock, then node modules. This order is very important. We're going to talk about these bottom 2 in detail in just a moment, but let's look at the very first layer, package.json. This again is the file that was just generated when we ran the npm init command. This package.json file is going to house the name and version of every single package that you install. To install a package in npm in your terminal, wherever you want it to be installed at, all you have to do is npm I space and then the package name you want to install. If there is a page for it on npm's website, it is a valid package to install. For example, we have Tailwind CSS pulled up, so we could run npm I Tailwind CSS just like this, press enter, and it will install Tailwind in our app. If I lower this terminal and you look closely at this package.json file, when you scroll down, you can see it added this tailwind.css to this dependencies object. The main thing to note here is that it's a key value pair, the key being the package name, that being Tailwind CSS, and the value being the number, which is the version number. You can see it's 4.1.17, which if we look over at the Tailwind docs right here, is the newest version. If we go over here and open our file explorer, you'll see that it also generated this package-lock.json file and this folder called node modules, but I'll go over those in just a minute. The important thing to know with package.json is that it is the entry point for all packages in your app. The second you install a package with the npm I command, it will add that package to your package.json. React is also a package. So if I go over here, I can search React again, find it, and you can see React is right here. So if I wanted to add React to my app, I could go into my terminal, I could just say npm space I space React, press enter, I install React in my app, and you can see it adds React to package.json. You can also install multiple packages at the exact same time by just separating the names by a space. So if I want to install multiple packages, I can say npm I can install Axios and Vite at the same time by saying Axios space Vite, press enter, and now it will actually install both of them in my app. So if I close out of this terminal now, you can see we have Axios and Vite both added. And now we have 4 packages in our app, again, all in this dependencies object. For each one of them, we have the package name followed by the package version. As people maintain and upgrade packages, their package numbers will go up. So for example, React 19 came out, I believe, earlier this year. So we're on React version 19. And the same is pretty much true for every single package. Usually big major updates will increment this first version number. So Vite might go from 7 to 8. But for the most part, minor patches will just increment these numbers here. By default, when running npm I, it will always install the latest version of the package, which is typically the behavior that we want. However, sometimes obviously you might need to go to an older version, especially if you're in an already existing app. So if you want to install a package that is an older version, you can say npm I, the package name, so Vite for example. And let's say I wanted to go to 6.3.6, I can just do the @ symbol, 6.3.6 like this, and doing this notation will install that specific version. Otherwise, it'll just do the latest, as I said. So this package.json file here essentially houses every single package name and version that you install in your app. It's basically just a file that keeps track of what packages your app is actually using. The code itself inside all these packages is nowhere near this file. It is just package name and versions that you're seeing right here. You don't really, for right now, need to worry about these other things inside of package.json, like up here. Your framework will normally take care of it for you. However, one thing I do want to mention real quick right here is this scripts object. Every single one of these keys right here that you see in scripts, so for example test, is a script that you can run using the command npm run. So if I wanted to run this test script right here, I could go into my terminal, I could do npm run, whatever the command name is, so test, press enter, and it will echo this error right here saying no test specified, exit 1. Which is exactly what this echo is doing. Normally, you might have a script called dev or something like this. Let me add a comma here. You might have a script called dev that would actually start your development server. So, it would do, Vite run or something like that. So to run the dev server, you would normally do npm run dev, or sometimes it's not called dev, it's called start. So npm run start. But essentially any script you have in here doesn't matter, just do npm run and then whatever the script name is called, and it'll go ahead and run that script. Another command you might commonly see is build, which will actually build and bundle your app with most frameworks. Same thing, I would just run something like npm run build and then it would work. I think you get the general idea. So essentially, this package.json file is two very important things. You have these scripts first, which is what I was just talking about, but more importantly, you have the dependencies where you have the name and version of every single major package in your entire app. This package.json file is the most important piece for your package system because of these dependencies that you see right here. However, it is only one piece of the puzzle. By itself, having the package names and versions doesn't really do much for us. This is where we need to look back at our three layers. Layer 1 is package.json, and it's what we just looked at. The very next layer is package-lock.json. And this part is going to be critical because honestly, a lot of people get these two files completely mixed up since they have similar names, but they are not the same thing at all. What is package-lock.json and how does it relate to package.json at all? Well, let's head over to the Vite page on npm so I can show you something. If we're on this page right here, we have this tab right here called dependencies. As you can see, it says that Vite has 6 dependencies. So if I click on it, we can see that there are 6 other packages, these packages right here, that Vite needs in order to run properly. So Vite is essentially itself dependent on 6 packages or else it can't run. And this is where we start getting into the web of things, because Vite itself is a package that requires other packages to run. When people talk about the interconnected web of huge dependencies in the JS package system, this is what they're talking about. We want to get Vite in our app to use their code, but internally, they're using other people's code to run their code. So for example, Vite is dependent on esbuild, fdir, picomatch, postcss, and these other packages in order to work. However, if we look back to our package.json, we just have the reference to Vite right here along with its version number. Nowhere in this file do we have any of these other packages that Vite is dependent on. This is exactly what package-lock.json is for. If we go over to our file explorer and we open the package-lock file, you're going to notice a couple of things. The main thing is that this file is huge. At its smallest, it's going to be thousands of lines minimum. Right now, this is at least 1200 lines long. If we take a quick look in this file, you'll notice we have all the packages that are present in our package.json. Axios, React, Tailwind, and Vite. However, if we keep scrolling a bit, look right here. We have esbuild. Why do we have esbuild in here? Because it's a dependency of Vite. We need esbuild in order for Vite to run properly. So what am I trying to show you? Well, this package-lock file is going to have every major package you install in your app, like how we have Axios, Vite, Tailwind, etc. And it's also going to have every single dependency of every package that we install. We've already seen esbuild right here. And if we look over at our Vite page, we can see that fdir is a dependency as well. So if I just control F in this file and I search for fdir, you can see we have this right here. We have an entry for fdir. If we again look over at our Vite page, you can see that postcss is also a dependency. So if I control F in here for postcss, boom, we have postcss right here and its whole entry. This is the reason why package-lock.json gets so enormous, because it essentially has every single dependency of every single package in your entire app. And sometimes packages have dependencies, those dependencies have dependencies, and the tree goes on and on. I can show you this directly because if I go over here to npm and I search up Axios like this, we can see that Axios has 3 dependencies: follow redirects, form data, and proxy from env. If I take one, for example, like this form data right here, and I go and I control F, form data, just like this, and I find the entry for form data, look at this. Form data itself has 5 more dependencies for it to even run. So Axios itself has 3 dependencies, and one of those 3 has 5 more dependencies. One of those dependencies right here is async kit. So if I go in here and I just search async kit, I can find the entry for it actually right here. And basically all I'm trying to show you is that package-lock will literally trace the entire tree and web of dependencies and subdependencies and list every single one in this file. And again, that is why this file is usually enormous. And this is one of those things that makes web development ridiculously complex. Almost every package you install is dependent on some other packages, and those packages are dependent on other packages, and the list goes on and on and on. Either way, every single dependency in your app and subdependency is going to be in this package-lock.json file. But the real question is, what information does this file actually have for each one of our packages, and what does it do for us? Let's control F and go back to Axios here to find this entry, and we'll break it down with this package. Every package in your package-lock file is going to have a couple of things that are inside of the object. So it's key value pairs, where the key is the node modules / the package name, colon, and then the value is the object, and we have a couple of fields here that I'll talk about. First, as I mentioned, packages evolve over time, so every package is going to have a version number just like this, just as we saw in package.json. If we skip this resolve for a second, we next have integrity, which is usually just an encrypted key that's basically there for security, but you don't really need to worry about this right now. License is usually going to be MIT, basically saying whether it's free use or not. And then this dependencies object right here is just going to be an object containing every package that this particular package needs to work. So if we look at Axios over here, we know that we are dependent on follow redirects, form data, and proxy from env. So you can see those three dependencies are in this object right here. And you'll notice that this structure right here of having this dependencies with the package name and package versions for each of them is the exact same structure as we have in package.json. So package.json has all of our major versions right here, and package-lock will actually go into the nitty-gritty and get all of our subpackages in that same format, just like this. The real important part of every single entry in package-lock is this resolved field right here. It's always going to be a URL. So you can see in this case, it's an HTTPS link linking to registry.npmjs.org. No matter which one of these entries I go to on npm, pretty much every single link is going to be to the same thing, npm.js.org. As you can see, they are all very similar links. So what does this link actually do? And what is it for? Well, I mentioned earlier in the video that npm is literally a massive store for every single JavaScript package ever. This resolved link right here that you see is a download link for the actual source code of the package. So if I take this whole link right here and I go ahead and copy it, I open up a new tab here and I paste it in, it will actually download the source code for Axios. So we know that this resolved right here is an actual link to the source code of whatever package is in question. Again, I want to iterate that every single package, meaning every dependency, every subdependency, and so forth, is going to have its own resolve link. So this one called call bind apply helpers is also going to have a link to its source code. Every single one is going to have resolve. I can just quickly scroll through this and you can see they all have this resolve field that link us to the actual source code that we need. The real question is now that we have all these links to the source code of all the packages, including the dependencies and subdependencies that we need, how do we actually use these links to do anything? What is their purpose? This is where node modules comes into play. If we look back at our three layers, we first covered package.json. Package.json has the major packages and their version numbers. When we install packages, it will look at those major packages and list every single dependency and subdependency those packages have in our package-lock.json file, as you can see here. That's what I just spent this last portion showing you. However, the way the package system works in JavaScript is that we don't just use it from some website. How packages are actually used is they're all installed onto your device or whatever server is hosting your web app. So we actually need to download the source code for every single package into our app. And that is how we're going to be able to use it. And that is exactly what this node modules folder is right here. If we look into the folder, it is going to be absolutely massive. This right here, the example I'm showing you, is actually super tiny compared to what it normally is on a full-scale project because we only have a couple of major packages. Normally, this is going to be hundreds or thousands of different folders in here. For example, we know that rollup is a dependency of Vite, so if we open up our node modules, we know rollup's in our package lock, so the folder for the actual source code for rollup is right here. And when I say source code, I don't always mean directly the actual source code, but really it's the deliverable code of the package. So I can start reviewing that code in here. If I open this dis folder, maybe go in bin, I can see what each of these things do. This is the actual code for rollup. If we want to find the code for React, we see we have this React folder right here. We can open up React, and we have all these different files that actually contain essentially the source code for React. Basically, what I'm trying to show you is that every single major package you install, plus all of their subdependencies, those packages' subdependencies, and literally every single package in the entire tree for your entire project is going to be inside of this node modules folder. Another one we've seen is fdir. We know it's a codependency of Vite. We also have esbuild and so forth. Just so we can really nail down what I'm talking about here, let's take a look back at Vite. So let's go in here. Let's search for the Vite package. Go ahead and click on it. And if we go to the dependencies of Vite, you can see that Vite needs 6 things to run properly. One of them is this package right here called tiny-globby. Meaning, if we head into our package lock file real quick, and we just Control F for tiny-globby, you can see the entry for it is right here, and we get a direct download link to the source code for TinyGlobby with this link right here. But if we look back at these dependencies here, you can see that TinyGlobby also has two dependencies, fdir and picomatch, which is why they're on the dependencies for Vite right here. So when we're building out node modules, what it would do is it would see that we have this link right here. It would go download that. It would see we have fdir. It would go download that using that link. It would also find the link for picomatch and download that. So now when we go into our node modules folder, we would have TinyGlobby right here, this folder. We would also have picomatch, and we would also have fdir. I think you see what I'm getting at here. If we look at it from a very high level, again, package.json has the major packages, names, and versions like this. Then we will go and find every single dependency and subdependency and put that in the package-lock file. And then we'll take the download link for every single one, download the source code, and shove it into this big, massive node modules folder. And that's the flow. I mentioned earlier in this video that in the vast majority of web apps, package code is going to be 90+% of your entire code base. In this node modules folder right here is exactly what I mean by that. Node modules in large or enterprise scale applications is going to be monstrously huge because it literally contains the source code for every single package in your app. In a normal app, you can expect most of the code you yourself write to be in the source folder, and typically your individual code will be completely dwarfed in size compared to node modules. And due to the nature of node modules, there are a couple of important considerations about it. First things first is that this node modules folder is a generated folder, meaning you as a developer are not responsible for directly modifying anything inside of it. So if I wanted to get silly, for example, and start modifying the source code for React, I could go down here and I could find React, find one of these files, say, okay, I want to open it up. Let me just start changing this and start, deleting code and saving it and whatnot. However, doing this is pointless because the very next time this node modules folder gets generated, my local changes will get overwritten. If for whatever reason you actually need to change the source code of an entire package, there are sort of ways to get around that, but that's way beyond the scope of this video and not necessary 99% of the time. As a general practice, you should never be touching any of this code inside of the node modules folder. Just leave it alone. Another important consideration is if this project is a Git project. If this project is initialized as a Git repo, so you're either working on a team that uses Git or you're just pushing and pulling down from your own remote repo, there is something you need to account for. In all Git projects, you can make a file called .gitignore that would look something like this. This is just a basic template generated by Vite, and most build tools will have some boilerplate for it that looks pretty similar. Everything mentioned in this file right here will not be taken into account when doing any actions in Git. It is important that if you're using Git, that node modules is in your gitignore file, just like it is right here. The reason for adding node modules to your gitignore is that you don't want to completely bloat your repo. I've said over and over again how huge this folder can get, and pushing this to your repo means that anytime you want to pull, or someone wants to clone the repo, it's going to slow things down by a ton for zero benefit. Node modules, as I mentioned, is a generated folder. So even if you're on a team, there's zero reason to push it to your remote repo through Git, because as long as someone has at least a package.json file or also a package-lock.json file that can just generate node modules. And what I'm insinuating by this is that in effect, in a typical Git environment, package.json right here and package-lock.json should both be included in your Git workflow. Node modules, however, should not. You should not include that in Git. Now let's get to the real meat of things. I've said over and over again that both package-lock.json and node modules are generated folders. Package-lock generates from package.json, and node modules generates from package-lock. This all comes back to the three-tier system. You start with package.json, and the other folders generate sequentially from there. But how do we actually generate package-lock and node modules? This is an extremely important aspect of this whole thing. The two primary commands that will generate these things are npm-i and npm-ci. They are two very similar commands, but have distinct differences. So let's talk about them real quick, starting with npm-i. npm-i is probably the command you've seen the most out of any other npm command. npm-i and npm install are the same exact thing. You might see both. npm-i is just the shorthand version that most people use. And npm-i or npm install has two primary functions. The first primary function is to install brand new major packages to your app. Like earlier in the video, I ran a command to add Vite to my app because I ran something like npm-i Vite, just like this. And whenever it did that and I installed Vite, it added Vite to our package.json. It added Vite and all dependencies of Vite to my package-lock file, which we can see here, plus all these subdependencies. And then it took all those and got the source code for every single one and added it to the massive node modules folder. If I want to, for example, add Vue to my project, I could go into my terminal. I could say npmi Vue, and that would go ahead and run really quick. It would add Vue to my package.json right here. It would add Vue and all of its subdependencies to package-lock and download the source code for all of them, and again, put them in node modules. So anytime I want to add a package to our app and have it go through all three layers, that being package.json, package-lock.json, and node modules, I can run npmi and then the package name. The second primary function of npmi is to simply ensure that your local dev environment has all the necessary packages and whatnot to run properly. Whenever you create a brand new project using something like Vite or any other build tool, or you're working on a team environment, one thing you'll be told to do pretty often is run npmi with no package names or anything, just by itself, like this. If I open my terminal and I ran npmi with no other arguments. What npmi will do by itself is look at your package.json file, and it will actually look at your major packages, and it will generate both the package lock and node modules. It won't just completely delete your package lock and node modules if they're already there, but it will check to make sure everything is in sync and will update the package lock and node modules to ensure everything is synced up how it should be based on the package.json file. npmi by itself like this should not modify your package.json file right here in any way. So this file, by running npmi by itself with no package names, does not modify this file. It will, however, update the package lock and node modules accordingly. Let me show you this in action. If I go into the terminal here, and I just run the command rm-rf node modules and also package-lock.json to completely delete both these files. So now if we go in here, we just have the get ignore and package.json, so we have no package lock, no node modules or anything. However, we still have our major packages that we have right here in package.json. This is the state that you'll usually be in when you first create a new project using a build tool. It's pretty common now to have a package lock included in your build tool, but you'll never start out with node modules ever, which is why if you use Vite, for example, it'll say the first thing you should do is run npmi before you run your dev server. So if I don't have package lock or node modules, I can run npmi in my terminal like this, and it will completely generate both these things, both the package lock file and the node modules folder. If I go into here, you can see now we have package lock and we have node modules. The way it does this is it looks at our package.json file, sees all of the major versions right here, generates a package lock based on all those major versions to find all the links and whatnot for the source code, and then it will use this package lock file to download all of that code into node modules. So the same system as before, but running npmi will make sure it is all set up properly. Just like that, after running that one simple command, I have an updated package lock and all the source code I need for my app to run. I mentioned a moment ago how using npmi makes sure that your package, package lock, and node modules are all completely in sync. Let's say I want to change the version of one of my major packages. So instead of using React 19.2, I actually want to use 18.1. So I can go into my package.json file, and I can change this to 18.1 now. So package.json says React is on version 18.1, but if I go into package lock and I search for React here, you can see React is still on 19.2 obviously, because we have not yet changed package lock to match accordingly, which means package and package lock are now out of sync. However, running npmi will fix that. If I open my terminal and I just run npmi like this, it will do it super quickly, look at all the packages and sync them up, and now package lock is also at 18.1 to match the package.json. And again, this is because npmi bases everything off of the package.json file, not the package lock. And that's a very important point that I want to make. When running npmi like this, your package.json file is the source of truth. This is what it will use. So if I change this 18.1 to be like 15.0 and then I npmi again, it will update package lock to match whatever package.json has, because package.json is the source of truth. And this is where I want to make a very important distinction with the other install command. I mentioned that npmi is one of the commands that you can use to install things, and it's the main one that I just showed you. However, one that you probably have not seen to the same extent is npmci. npmi and npmci both install things, but how they work is quite different. npmi, as I just showed you, bases everything that it installs off of your package.json file right here. However, if I instead change this from npmi to npm ci, just like this, it will not use package.json as the source of truth. It will actually use package-lock.json as the source of truth instead. So what does this actually mean in reality? Let me go back over here and go ahead and delete our node modules folder. So I just deleted node modules, but I still have a perfectly intact package.json and a perfectly intact package-lock.json. If you're in a situation like this, where your package.json is fine and your package-lock.json is fine, and you only need to get your node modules, so basically the source code for all your packages, you should just run npm ci like this instead of npmi. npm ci does not care about your package.json file at all, so it doesn't care about any of this. All it cares about is your package lock. All it will do is if I run npm ci right now, it will just look at our package lock, get all of the links it needs through all these resolve links right here for the source code, and it will just go through every single one of these and install the node modules folder. However, before it runs, one thing that it will do is actually check to make sure the package lock and the package.json are actually in sync. Because if your package.json and your package-lock.json are not on the same page and not perfectly in sync, you cannot run npm ci. Let me show you what I mean by this. For example, if I go back and I change the React version again, let's say we're at 18.1 and we already ran npmi, so we know that package-lock.json is also at version 18.1. So right now they're perfectly synced up, 18.1 in both. But if I want to mess it up for whatever reason, I can say 19.2 right here, and now my package.json version is different than my package-lock.json version. If I now try to go into my terminal and I try to run the npm ci command just like this, I'm going to get this error. It will basically just say this right here. npm ci can only install packages when your package.json and package-lock.json are in sync. Please update your lock file with npmi before continuing. So it is exactly what I mentioned. npmi will sync up your package and package lock, npm ci will not. So if they're out of sync like this, you'll need to run npmi instead. If I run npmi, now they're both synced up and we're good to go. However, if they are already in sync like they are here, just run npm ci. And what I just mentioned was honestly a lot of information, so let me show you a super quick chart of when you should use npmi versus when you should use npm ci. If you need to add or update packages, npmi. If you want to generate both package lock and node modules, npmi. If you want to make sure package and package lock are in sync, npmi. If you just need node modules, npm ci. If you're working on a team where people are constantly updating package lock and pushing it up, npm ci. This goes hand in hand with the above point, because if people on your team are updating package lock and push it, you should get the fresh package lock when you pull down, meaning all you need is the new node modules. Therefore, npm ci is sufficient. If you're building your project or deploying it to production environments, npm ci, not npmi. This list is not exhaustive, but it's a few of the main examples I could think of. In my opinion, here is the mindset that you should adopt that will help you decide when to run npm ci versus npmi. You should prioritize npm ci first, meaning anytime you need to mess with your packages, ask yourself, would running npm ci fix my issue? If it will, great, just use that. If it won't, use npmi as a fallback case. The reason I say to prioritize npm ci over npmi is because it's less overhead and it is safer. Safety is the reason why on this list here, I mentioned you should only be using npm ci for production environments. Whenever you build your project onto a server, your package and package lock should already be in sync, meaning you only need to run npm ci, there is no reason to run npmi. Running npmi for production environments introduces safety issues and vulnerabilities. I won't get too deep into this, but recently there was a major npm hack that caused a lot of commotion, and part of the reason it was successful was because people ran npmi in their production environments instead of npm ci. What that was doing is every time the server would build out the app, it would possibly update the package lock and install brand new code into node modules every single time. Meaning essentially on every build, some apps were adding thousands and thousands of lines of new code for practically no reason. And you really have no idea what new code you're adding when you run npmi, and if npm somehow gets compromised, you could just end up adding malicious packages to your dev server when you run it. Obviously, the odds of that are super low, but it is possible. npm CI, on the other hand, will only install exactly the code that is in your package lock. So if your package lock is safe and doesn't contain any compromised packages, npmi is 100% safe and will not introduce any new random code into your app. This is why it's preferred when you're building your project to a server or production environment. Now that we've gotten this far, I want to end the video with a super quick best practices. These will just be super simple bullet points that you can follow going forward. Do not directly edit package lock or node modules. These files are both generated, there's zero reason to modify them directly. If you want to change them, do so with npm CI or npmi accordingly. If using Git, push packages and package lock, do not push node modules. If you push package and package lock, that will ensure yours and everyone else's package files are in sync, allowing people to just run npm CI to get the updated package code. It keeps it super clean. Next, prefer npm CI to npmi when able to for the overhead and security reasons I mentioned just a moment ago. And lastly, when building for production, use npm CI, not npmi. npmi is completely fine if you're working by yourself or just working locally, but the second that production comes into question, you want to be using npm CI instead. And that is pretty much it for the best practices. These all stem from common best practices and things that I've learned or experienced firsthand as a professional web dev. With that being said, that's going to wrap up this video. I hope this video gave you a good sense of how the npm package system works in JavaScript and a great idea of how to utilize it properly going forward. Take care everyone, and I'll see you in the next one.